All right, so today we're going to be looking at section 8.3. It's on graphing general rational functions. So our goal is to graph the rational function with higher degree polynomials. Okay, so what we're going to do is take the equations that we've done in the past, and we're going to look at a kind of a general rule of how to graph all rational functions. So if we look at the graph of rational functions, we're going to take the equation and we're going to look, it says, let P of x and Q of x be polynomials with no common factors other than 1 and -1. So my P of x is going to be here, and my Q of x is in my denominator. Now, if you want to follow along with this stuff or look at the formula, it's in your book on page 565. That's where we're going to be starting from. But it says the graph of the following rational function has the characteristics listed below. So f of x is our function, and then we're going to have P of x in my numerator and Q of x in the denominator. Now, when we write this, we're going to write the general form of this, and I'm just going to write this first term to start with, because that's the one that we're going to be looking at. So we're going to have a coefficient, and then the sub n, and the exponent will be n as well. And we'll look at what those things mean later. Now, there's three things that we have to talk about when graphing these general rational functions. First, step one, it says the x-intercepts of the graph of f are the real zeros of P of x. Okay, what does that mean in your own words? Who can tell us? Perfect. We have to set the numerator, which is P of x, equal to 0. That gives us our x-intercepts. Okay, so if you set the numerator equal to 0, that gives you your x-intercepts, your values where it crosses the x-axis. Okay, good. Step 2 says the graph of f has a vertical asymptote at each real 0 of Q of x. What does that mean? And do what with it? So we're going to set the denominator equal to 0 and then do what with that equation? Solve it, right? Set it equal to 0, solve it. The answers that you get will be your vertical asymptotes. Okay? So the numerator will give us our x-intercepts. The denominator, if we set it equal to 0, will give us our vertical asymptotes. Okay? Those are the two things, steps 1 and 2. Now, step 3 is kind of like the stuff that we talked about yesterday, but it says the graph of f has at most one horizontal asymptote. So you can have one, or you could have how many? 0, right? We won't have any. Okay. Now, vertical asymptotes, we can have a number of different vertical asymptotes. Okay, but we can only have one horizontal asymptote, and we might not have any. And here are the rules that we have to look for here. All the problems we did, well, not all of them. Most of the problems we did yesterday fall into this category right here. Okay, where m is less than n. Now, m is the degree of the top polynomial. N is the degree of the polynomial in the denominator. Okay, so yesterday we looked at equations that looked like this. Y equals 3 over x, right? What's the degree of the numerator? What's the degree in the numerator? It's a constant, so what degree is it? 0, right? It has a 0 degree. Because I could write this as x to the 0 power, right? What's the degree in the denominator? 1, right? Okay, so the degree in the numerator is 0, the degree in the denominator is 1. So that means my degree in the numerator is smaller than the degree in the denominator, which means my horizontal asymptote is what? 0, y equals 0. Because that's what it says right here. Okay, so that's how we find the horizontal asymptote, which is what they were the other day, right? Now, let's say we take this and look at the second one. It says m equals n. And we had a couple problems just like this at the end of the assignment yesterday, right? where we're going to look at y equals something like 2x minus 3 over 4x plus 5. Now it says if m equals n, the line y equals a to the a sub m over b sub n is the horizontal asymptote. So what are we going to do? We're going to divide those two. So what's my horizontal asymptote going to be? Y equals 1/2. Okay? So our asymptote here in this case would be y equals 1/2. So if the degrees are the same, you divide the leading coefficients. 2 divided by 4. Okay? That's it. And then the third one says, what if the degree in the numerator is bigger than the degree in the denominator? Well, what does that tell us? There won't be any horizontal asymptotes. There just won't be any in this situation. Okay? Does that make sense? So 3 things we're always going to check. 1, set the numerator equal to 0. That's going to give us our x-intercepts. 2, set the denominator equal to 0. Solve it. That gives us our vertical asymptotes. And then 3, we have to look at the degrees of these polynomials in my numerator and the denominator. Okay? If the degree in the numerator is less than the degree in the denominator, it's y equals 0 is the horizontal asymptote. If the degrees are the same, we divide the leading coefficients to get our horizontal asymptote. And if the degree in the numerator is bigger than the denominator, then there isn't one. Okay? Questions on that? All right. Well, what we're going to do is we're going to look at a couple of examples. And the first one we're going to look at is what happens if the degree in the numerator is smaller. So what do you think the first thing we're going to do is? Set the numerator equal to 0, right? We want to find that first. That's step 1. So 4 equals 0. All right, what's that tell us? Is that possible? No, what does that mean? No x-intercepts. Which means my graph will never touch the x-axis, right? So, second one, what are we going to do? Set the denominator equal to 0. Solve it. Well, what do? Subtract 2. Now you're good. Take square root. X equals, it has to be plus or minus, right? The square root of negative 2. What is square root of negative 2? It's an imaginary number, right? So what does that mean? There are no vertical asymptotes. All right. Now let's look at the degrees of my polynomials. 4 has a degree of what? 0. X squared plus 2 has a degree of what? 2. So numerator degree is smaller than the denominator degree, which means what? Horizontal asymptote is 0. Okay. Horizontal asymptote 0. So now what are you going to do? Right, we're just going to plug in numbers. So let's make a table of values. So we're going to have x and y. What number you want to put in? 0. Let's start with 0. Put in 0. What do you get? 2. Okay, put in 1. What do you get? 1 squared is 1 plus 2 is 3. 4 thirds, which is 1 1/3. Okay, so 0, 2, 1, 1 1/3. Put in 2. 2 squared. 4 plus 6. Or sorry, 4 plus 2 is 6. 4 6 is 2 thirds. Okay, so this is 2 thirds. Now, as we keep going further, what's going to happen? It's going to get closer and closer to 0, but is it ever going to touch it? No. So do I need to keep putting in points on that side? Absolutely not. We know what the graph's going to look like. I'm just going to continue it going like that. But now what do I have to do? Right, let's put in points on the other side. So let's put in negative 1. Negative 1 is going to give me 1 plus 2 is 3. 4 over 3 is 4 thirds. So that's 1 1/3. Well, what's going to happen on this side? It's going to be exactly the same. So I'm done plotting in points. I just know my graph's going to look like this, and there is my graph. Okay? Now, if they ask us for the domain, What values can I have for x? All real numbers. No restrictions? Is there any values I can't have? Why? I can square it. Right? I can put any number in for x. So it is no real numbers. Or, I'm sorry, all real numbers. How about my range? You're right, it can't be 0. Look at my graph. Okay, can it be 0? No. Can it be 2? Yes. So we're going to say y, we're going to have 0 here and 2 here, right? So it can't be 0, we said, so it's got to be greater than 0, right? It could be equal to 2. So that would be my range. 0 is less than y, which is less than or equal to 2. Okay. Questions on that one? Does that kind of help clear some of the stuff up you did yesterday? All right, so now what we're going to do is let's look at the next example. We're going to go to example 2. Now in this case, we're going to have this one. First thing, what is our first step? Good. Set the numerator equal to 0. So it's going to be 3x squared equals 0 and solve it. So we're going to have x squared equals 0, which means x equals 0. That means I have a point right there. My x-intercept is 0. I only have one time where this graph's going to cross the x-axis, and there it is. It's at 0. Second step, set the denominator equal to 0. So now I'm going to have x squared minus 1 equals 0. What are you going to do? Solve it. X squared equals 1. X equals plus or minus the square root of 1, which is plus or minus what? 1. So how many vertical asymptotes will I have? 2. I'll have one at 1, and I'll have another one at negative 1. So I'm going to draw that on here. Oh, right here. At 1, so x equals 1, and x equals negative 1. Okay, so there are my 2 vertical asymptotes. Now, notice the degrees here. What's the degree in the numerator? 2. What's the degree in the denominator? 2. They're the same. What does that mean? What do I have to do? Divide these 2 coefficients, right? So what is it? 3, right? 3 divided by 1 is 3. So it has a horizontal asymptote at y equals 3. Okay. So now we have all of our asymptotes on there, and now what are we going to do? Plot some points. All right. I'm going to erase some of this so we can see what our original equation is. So we're going to make a table. Well, what number do you want to plug in?
0.
Oh, we don't need to plug in 0. I already got it, right? You can't plug in 1. That's on an asymptote. Let's start over here. So let's plug in 2. Okay? Good luck. It won't give you anything. 2 squared is what? 4 times 3. 12. Okay, so this is 12 over 2 squared minus 1, 3. So what's 12 over 3? 4. So 2, 4 is a point. All right, let's put in another one on that side. Let's go 3. What's 3 squared? 9 times 3? 27. So we have 27 and 3 squared is 9. 9 minus 1 is 8. So what's 27 divided by 8? 3 point something, right? Through what? 3 and 3/8? So and I really don't care what it is. I just need to know somewhere here. Because 2, 4 is right here. This one is 3, 3.4. Okay. Now, that's all I need. Because I know what's going to happen to this graph. It can't cross here, and it can't cross here. So it's going to get infinitely close to here and here. And so it's going to go like this. Right? Just like the hyperbolas we drew yesterday. Now, let's go to the other side. So let's put in negative 2. So what's negative 2 squared? 4 times 3, 12. Negative 2 squared, 4 minus 1. 12 divided by 3, 4. So that one's going to be right here. Well, if I put in negative 3, what am I going to get? Okay, so my graph here is going to go like that. Right? Now, what am I missing? The middle part, right? I'm missing the middle part. So we have to graph that part. Now, here is the thing. What am I going to have to put in? I'm going to have to put in a half. We already have 0 here, right? We know that that's a point. Because I need to know what happens in between here. So what we're going to do is we're going to put in a half. Well, what's a half squared? 1/4. Right? So this is going to be 3/4 divided by, what's a half squared? A fourth. A fourth minus 1 is negative 3/4. Well, what's negative 3, or what's 3/4 divided by negative 3/4? Negative 1. So, oh, that's not right. I'm putting in a half there. At a half, we're at negative 1. So that's right here. So what's my graph in there going to look like? Okay. So there is your graph. You do have to be careful because there are points that could cross the asymptote. Usually not, but like it could be an asymptote for this part of these parts of the graph, but maybe not for this part of the graph. It's weird, but yeah, but you would assume that it would go down, and so if you don't, you would want to double check it. Okay, so that's our graph. Okay, questions on that? All right, let me ask you a couple more questions on this. Domain. Who thinks they could tell us the domain? No. Good. All real numbers except it can't be negative 1 and it can't be 1, right? Because they're not in our domain. They're not values of x. So x cannot equal 1 and x cannot equal negative 1. How about a range? Okay, you're right. It can't equal 3. So it has to be greater than what? Okay, so there's part of it. Y must be greater than 3, right? Oh, sorry. Y is greater than 3. There you go. Or what? Can it equal 0? Yeah, so less than or equal to. Okay. Or y must be less than or equal to 0. Okay. So there's our domain and our range. You'll go on forever. So really what they're saying is it can't be in between here. Right? So these are the numbers that it can be. Y has got to be bigger than 3 or less than that. Say that again. No. You can't, because if it's a compound inequality, you can't have the signs go in opposite directions. Okay. So that's a good question. Okay? All right, we ready for the next one? All right. Now, in example 3, it says graph the rational function if m is greater than n. Now I'm going to erase this because we're going to need that spot. All right, so again, what are we going to do first? Set the numerator equal to 0, right? X squared minus 2x plus 3 equals 0. Solve it. So what are we going to do? No. Factor it. Oh. I thought you said we're going to minus 3. I'm like, no. We're going to factor it. Right? So, x, what else we have? minus 3 plus 1. So what is x going to equal? 3 and negative 1. What are those? X-intercepts, right? Those are my x-intercepts. Those are the places where my graph will cross the x-axis. Okay? So now, what do we need to do? Set the denominator equal to 0. Well, that's easy. What is it? 4. So what does that tell us? That's my vertical asymptote, and it's at 4. Yeah, that part's pretty easy, right? It's really easy when it's just a binomial in there without a squared, when it's just linear. Okay? So now, there's what? Why is there no horizontal asymptote? Right, the degree here is in the numerator is 2. The degree in the denominator is 1. 2 is bigger than 1, which is in the numerator, so there is no horizontal asymptote. We won't have one. Okay, so now, yeah, let's just graph it. Which side do you want to graph first, the right or the left?
The left.
All right, so let's graph the left. Well, we have, so you want to put in 1? All right, let's put in 1. This is going to be 1 minus 2, which is negative 1, minus 3, which is negative 4. Okay, and what's 1 minus 4? So what's negative 4 over negative 3? 1 and a third. Okay, so 1 and a third. Okay, so now, well, let's put in 2 as well. Okay, let's put in 2. So 2 squared is 4 minus 4, so that's going to be negative 3. And what's 2 minus 4? Negative 2. So that's going to be at 1.5. Okay. So we know that this general graph is going to come, and let's put another number. Let's put in like, let's go all the way over, like negative 5. Okay. All the way over here. Okay. So this is going to be 25 plus 10, which is 35, minus 3, which is 32. And then what's negative 5 minus 4? Okay, so what's 32 over negative 9? Negative 3 point, okay, so negative 3.55, so somewhere in here. Now, that's enough to give us a general idea what this graph's going to look like, right? This, x equals 4 is a vertical asymptote, so what's it going to do on the right side? Get really close to it, then it's going to turn this way and go like this. What's that? These are my x-intercepts. Well, we only had one intercept. What's that? What? This? Right here. It's like negative 3.5-ish. Okay? So now that's the left side. Question? If I plugged in 3? Negative 3? It's just gonna, it will just tail off that way. So, okay. And we know that this is going to go toward the axis of symmetry, or the the asymptote there. Okay. Now let's do the right side. So let's put in 5. Everyone, put in 5 quick. What do you get?
32 over 32.
No.
12.
It's 12, right? So if you put in 5, 6, 7, 8, 9, 10, 11, 12. So if you put in that, it's going to be up here. Let me go green, since we already used green. Okay? Yeah. All right, so now let's put in, what? 6. Put in 6. What do you get? Yes. 10.5. Okay, put in, well, we got to keep going until we know what that graph's going to look like. So you have to graph the whole graph. This is part of your graph. It's all right. So put in 7. Did you graph it? Oh. All right, so now let's do 8. Put in 8. Okay, so it's going back up now, right? So realistically, what's going to happen is this one's going to go toward this asymptote here, come back down, and then go this way. Okay? So that's the graph of what ours will look like. As soon as you get that pattern where it's going back up, it'll just keep going that, yeah. So, yes. All right, that's what I got here too. Oh, for the vertical asymptote, we set that equal to 0. So I just went x minus 4 equals 0, and then it's x equals 4. So the vertical asymptote is always what makes that denominator equal to 0. We just didn't write it down that time. Yeah, those are your intercepts. Yep, so the 3 and the negative 1, those are these points right here. Okay? And the denominator, this gives us our vertical asymptote. And then the degree tells us where that horizontal asymptotes are. Okay? So, questions on that? All right, that's where we're going to stop today. So, here is your homework assignment. It's on page 568, numbers 1 through 13, and then 15 through 23 odds. What's that? So that's what I would like you to do for your assignment for tomorrow. Quiz tomorrow is going to be on sections 8.1 and 8.2 only. Okay? No.